Okay. Okay. Good morning, everyone. Okay. அது எந்த தான் சைலண்ட்ல தான் போட்டுட்டேன். Okay. Thank you, Ansu. Good morning, everyone. Myself Priyadarshini. Today we are going to see about the topic upper confidence bound algorithm in reinforcement learning subject. So first of all, before moving into the topic, let's see what is reinforcement learning. Let me give the short introduction about the reinforcement learning algorithm in machine learning. Reinforcement learning is a kind of learning strategy used by our machines, which learns the environment using feedback. It learns to survive in the environment using the feedback which it has been received from the environment. The agent receives the feedback. Agent works on the environment. That means for a particular input, for a particular set of state, it exhibits some set of actions as per the input received. Then according to the feedback which is received as per the action performed by the agent, it will do the action further. So, and the main aim of the reinforcement learning algorithms model is to earn the highest cumulative of rewards. What is mean by reward? Reward is the set of feedback. It can be a positive or negative penalty about the environment in order to perform the action further. So the main aim is to receive the highest amount of rewards. Then in reinforcement learning models, we will be seeing two set of terminologies. That is, one is exploration and exploitation. Those both terminologies are very important in the reinforcement model. Then what is meant by exploration? That is the agent which is trying to explore the environment. That is, it is trying new set of actions in order to receive the reward from the environment. And what is exploitation? Exploitation, it is receiving the reward by performing the known action. So exploration is exhibiting the new set of action into the trying new input, trying new set of action for the received input. And exploitation is it knows the action what has to be performed, then performing the action and receiving the reward as per the action performed. That is exploitation. So in any kind of reinforcement model, this exploration and exploitation should be balanced. It should not be one should be high and one is low. If that kind of problem occurs, it will lead to the making a bad decision because the in reinforcement learning, the agent has to make a decision by itself. That is the main motive of reinforcement learning when compared to our supervised or unsupervised learning. So the agent has to make a own decision like a human, how the human acts, human thinks. So it has to make a decision about the environment. So these two terminologies, exploration and exploitation, plays a major role in making a decision. These both has to be trade-off. It has to be balanced. Exploration and exploitation of a particular agent in any environment should be balanced. So, if in case, let me say an example. Let us consider the vacuum cleaner example. If the vacuum cleaner is exploring more in the environment, that means it just roaming in the particular environment without cleaning the dirt in the particular place. And if it is doing more exploitation, means it is cleaning only the known places. It doesn't moving to the other unknown places in order to receive the reward. So both has to be balanced out. So that is the main problem in reinforcement learning. So for balancing this exploration and exploitation in reinforcement learning, we are having several algorithms like epsilon greedy, Thompson sampling, gradient descent, and upper confidence bound. In that set of algorithms, upper confidence bound algorithm plays a major role in balancing of trading of the exploration and exploitation problem. So, what is meant by UCB? UCB is a upper confidence bound. Then that is the algorithm which helps to solve multi-arm bandit problem. What is meant by multi-arm bandit problem? Let us consider if you are having, we'll be in casinos, they will be having multiple games. So, in that, this is the bandits. banded A, let me consider A, B and C. So it will be having some arm in order to pull. So if you see in casinos, they will be having that arm machines. If we pulling that arm machine, as per the force we have pulled, or else as per the force we have hammered, it will show some point, some reward. That is the reward gained by the user who is playing that particular machine for a particular period of time. So here the multi-arm bandit problem. So here, if the agent enters into any new environment, it has to make a decision. If it has to make a decision, so the problem is like a multi-arm bandit problem. So that it will be in the dilemma state whether we need to explore or we need to exploit. Like this, the agent will go to the dilemma state. So that kind of problem is called multi-arm bandit problem. So initially they have named it using this multi-arm game. So in RL model, the multi-arm bandit problem is the problem which occurs when we need to balance off the exploration and exploitation problem. So UCB is a major algorithm. It's the primary algorithm for solving that multi-arm bandit problem in any kind of RL model. So the main motive of this UCB algorithm is to balance exploration and exploitation. Exploitation issues. And the main idea is to select So the upper confidence bound algorithm helps to solve the multi-arm bandit problem. That means in sentence we can say it as in order to trade off the exploration and exploitation problem in RL model. That it helps to make the agent balance the exploration and exploitation procedure. Then the main idea is to select the action based on uncertainty, not only based on their estimated value. If it is based on their estimated value, then the exploitation value will be high than the exploration. So in order to balance it off, it also helps to work on the uncertain environment, because any RL model, if it is a supervised learning model in machine learning, it will have a certain set of input along with the trained value, the labeled value, and also in the unsupervised, it will be having some certain set of training. But RL model, we can't assure that all the environment will be known to the will be the certain environment to the agent, known environment to the agent. So in order, it may face uncertainty situations in the environment. So it works based on the uncertainty. That means if a vacuum cleaner, if we have implemented a vacuum cleaner into an unknown room, it will be moving to all the corners of the room in order to clean the dirt. So based on the uncertainty. Okay, now let's see the steps involved in the UCB algorithm, upper confidence bound algorithm. So the first step is to initialize the machine, all the banded multi-arm banded machines, which has several rewards as per it has been played. Then we have to play the machine, and in order to maximize using, this is the formula for UCB algorithm. So in this, the mu I is the average value, that is the mean value of all the machine, all the rewards received from the machine. Okay. Then beta is the value which is considered as 1, that is for probability. Then this is this 2 ln and of n. The ni is the how often the machine I is played so far. Then n is the summation of all the number of turns. So ni is the number of rounds played in a particular machine, particular arm. Then n is the summation of all the n's, so total number of arm played. So let me explain this with an example. So let us consider the example for solving multi-arm bandit problem using UCB, upper confidence bound algorithm. So as I said earlier, the main aim of the any RL model not is to maximize the cumulative amount of reward, earn the highest amount of reward in that particular environment, because earning the highest amount of possible rewards will help the agent to make a better decision in that environment further. So this is the example which I have considered. We here they have given that 3 bandits, that means 3 multi-arm bandit machine. So arm bandit machine, if you pull that machine, you will be receiving the reward for particular pull. So we are going to play with that machine. So here they have displayed 3 set of 3 very various machines. Say, and these are all the set of rewards already received from those machines when the player played. Okay, so in that first machine they have played 6 times, and these are all the 6 rewards they have received respectively. And in the second machine they have played 2 times, and the 8 and 12 are the rewards received. And in the third machine 5 and 13 they have played 2 times. So this is the rewards received from each bandit. So here what the question has been given, what we have to find is that in order to maximize the set of reward, which bandit will be the better. That means we need to find the optimal bandit for receiving the highest amount of reward if we play further. Let me draw the table here so that I can solve that side. Bandit, the rewards received for each pull. So let me write in short: B1, B2, that is bandit 1, bandit 2, and bandit 3. Then the rewards received is 8, 7, 12, 13, 11, and 9. This here 8, 12, 5, 13. So we know the formula for UCB, that is UCB is equal to mu I. Mu I plus beta into square root of 2 ln of n divided by n I. This is the formula for solving UCB problem for any multi-arm bandit problem. Then, so here we know that mu is the average of the rewards which has been received so far. Sorry, average of here mu is the average of number of times played in each bandit so far. So here So we know that this is the formula for UCB problem, for solving UCB problem. Here mu is the average of each set of rewards, average of rewards for each bandit. Then beta is the value, we consider it as a 1, and here n is the total number of turns played by all the bandits in the given set. And Ni is the I here is the machine, particular individual machine. So here Ni is the number of rounds played in a particular machine. So we can find the n at the initial before solving for each and every bandit. We can find the n here. Number of times bandit 1 was played. Here the bandit 1 was played 6 times. Since we are having 6 rewards, right? So 6 times it has been pulled. Then number of times the bandit 2 was played, that is 2, because we are having 2 rewards. Then number of times the bandit 3 was played, that is also 2. So n is equal to 10. So this is the common value we can find before started solving the UCB algorithm problem, multi-arm bandit problem. So now we know the formula for UCB algorithm and also the n value. N value is 10. So while solving, you have to remember that here we can use only n. Here it is Ni. That is for a number of turns for a particular machine, not on the whole. Now for bandit 1, we are going to solve for all the 3 bandits. Then we are going to finalize which is the optimal bandit to play further. That is which is having the maximum amount of reward. So for bandit 1. So now we have to find, we have already found the value n. Now we have to find, we know that beta is 1. So we need to find just 2 values, that is mu and n. So mu, we know that mu is the average of rewards which has been collected so far. That is, we have to take an average of this value. 8 plus 7 plus 12 plus 13 11 plus 9. So divided by total number of rewards. Okay. So if you calculate this, you will be getting 10. Okay. If you add all this and divide by 6, you will be getting 10. That is mu I value. Then we have to find, we have found this value and we know this and we know this. We have to find the Ni value. Ni is equal to what number of times the particular machine has been played. That is, we know that 6, because we are having 6 rewards. Now you have to put up all the values into the formula. Then we have to find the reward value. CB is equal to 10 plus, we know that beta is equal to 1 and square root of 2 ln of 10 divided by 6. So you can use your calculator to find the logarithmic value. Then it will be 0.876. So that is 10.876. So this is the UCB value for the bandit 1. We can note here UCB bandit 1, the value is 10.876. Now we have to find for bandit 2. So same we have to follow that mu I is here. We have to average the number of rewards received. So 8 plus 12 divided by 2 is equal to 10. That is 20 by 2. Then we have to find the Ni value. So that is the number of rewards, that is for that particular machine, that is Ni is equal to 2. So put up all the values into the formula again. The UCB, we can also use as 2 because here we can. is equal to 10 plus, we know the beta value is 1, then 2 ln of 10 divided by 2. So the value will be 10 plus 1 point. After calculating, it will be getting this value. So 11.517. This is the reward value for second banded using UCB algorithm. Then for banded 2, it is 11.517. Now we have to calculate the same thing for banded 3. So in your exams, you will be receiving more number of bandits. So we have to calculate for each and every bandit using the same formula. So for everything, we will be having the difference. We need to find the value mu and the ni for individual machine, and n value will be calculated on the whole before itself. So now for bandit 3. Here mu I is equal to 5 plus 13 divided by 2. So the value is 9. Then since 18 by 2, then ni is equal to 2 because the number of times the machine was played is 2. Now using UCB formula, we have to solve 9 plus 1 into 2 ln of 10 divided by 2. The same thing, 9 plus 1.517, that is 10.517. Okay. Okay. Now we have found the reward value for all the 3 bandits. All the 3 bandits of all the 3 given bandits using we have solved it using the UCB algorithm. So this is the reward value for each and every bandit, separate value. The main aim of, as I said earlier, the main aim of any kind of oral model is to maximize the set of cumulative amount of reward in any particular environment in order to make a better decision about the environment further. So here, after the calculation, we have the value for bandit 1 is 10.876, and for bandit 2 it is 11.517, and for the bandit 3 it is 10.517. Here the value of bandit 2 seems to be higher when compared to the bandit 1 and 3. So, but according to the value, total amount of value, we should not consider, we should not conclude the optimized bandit as bandit 2. Here we have to consider the entropy value. Entropy value is here that 2 ln of n divided by n is the entropy value for each and every bandit. So for that, for bandit 1, the entropy value is 0.876. So for bandit 2, it is 1.517, and for bandit 3, same 1.517. So this is the entropy value. That means excluding the average value, the remaining value is the entropy value. So here, even though the bandit 2 has the highest cumulative of value, that is 11.517 when compared to bandit 1 and bandit 3, the entropy value of a bandit should be lesser. So after calculating, we need to consider the entropy value. The bandit which is having the lesser entropy value will be the best bandit to play further. So according to that, bandit 1 is the best bandit. That means as per the three multi-arm machines displayed, bandit 1 machine is the better machine to play further. So since it has the lower entropy value as 0.876 when compared to bandit 2 and 3, both are having the higher value of 1.517. So likewise, we need to conclude, even though we are having the higher value, as per the lesser entropy value, we need to conclude that the machine, which machine should be the better machine to play further. So this is all about upper confidence bound algorithm. So in this lecture video, we have initially we have seen about reinforcement learning. So I have just given just 2 or 3 points about reinforcement learning. That way, the model, any kind of model which performs any set of actions into the environment as per the input received, as per the state, and then it will make a decision about better decision about the environment, like we humans do. And it will make a decision based on the feedback which is received from the particular environment. And the main aim of any reinforcement model is to receive the highest amount of highest cumulative of rewards from that environment in order to make work better in that environment further. Then in any reinforcement learning model, we'll be hearing or we'll be facing two set of problems. It may be a problem, but it is the mandatory one for a model, that is exploration and exploitation. So exploration is trying a new thing into the environment, trying new set of input into the environment in order to make a different decision and in order to receive various rewards. Then exploitation is doing known action into the environment in order to receive the good amount of rewards. Okay. Then what is UCB? UCB is a upper confidence bound algorithm. Here, if any model explores more in the environment, it will not receive the rewards, expected amount of reward. If it is exploits more, it will not try the new input into the environment. So both exploration and exploitation has to be balanced. It has to be trade-off. So UCB is one such algorithm which helps to balance the exploration and exploitation problem. And here next we have seen the steps involved in UCB algorithm. Then we have solved a multi-arm bandit problem using UCB algorithm. Then after applying the UCB algorithm, we have found which bandit is best to play for the player in order to that. Here, as per the entropy value, even though the calculated value is higher for bandit 2, the lesser entropy value should be considered for the choosing the best arm to play further. So according to that, bandit 1 has the lesser entropy and also higher value. So bandit 1 is best to play further. Thank you.